Welcome to Balancing Chemical Equations. We are going to pick up where we left off when we talked about skeleton equations and take the next step so that they can be truly meaningful chemical equations that give us all of the pertinent information. I want to touch right now on the law of conservation of mass and what it really means for us during chemical reactions. So during a reaction, the mass of the products is always going to be equal to the mass of the reactants. Okay, it's impossible for matter to be created or destroyed during a chemical reaction. And what that really means for balancing chemical equations is the number of atoms on each type must be balanced on each side of the equation. So on each side of the equation, you need the same number of each atom as on the other side. There are 6 rules for balancing equations. We're going to go through those 6 rules and then try an example problem and then give you a practice problem to try on your own, which will then go through the solution. The first rule or step is to determine the correct formula for all of the reactants and all of the products. This was also a part of your skeleton equation process, so that shouldn't be new. That should be a step that you've already been able to implement. Step 2 is writing the skeleton equation. If you're having trouble with this step, check in with last lesson. Number 3 is to determine the number of atoms of each element on each side. What I do is I set up a grid, which you'll see later on in this video, and make a list of each type of atom. Then I strictly count the number of each type of atom, both on the reactant side and on the product side. Step number 4. You need to balance the elements one at a time using coefficients. It's very important that you don't change any of the subscripts in any of the chemicals involved in the reaction. If you change the subscripts, then you are actually changing the chemicals. Okay? You can only change the coefficient. That's the number that comes before any of the reactants or products. If there is no coefficient by a species in the reaction, it is assumed to have a coefficient of 1. Number 5, once you've balanced all of them, you need to check each atom. Count them again at the end to verify that the numbers equal on each side. And finally, number 6, if all of the coefficients are a multiple of 2, then you can divide by 2 to get the lowest possible ratio. You want to make sure that the final balanced chemical equation is in the lowest possible ratio. Okay, I've got an example ready for when solid aluminum reacts with a silver chloride solution to form aluminum chloride and solid silver. So the first thing that we're going to do is recognize that we already have all of the chemical symbols converted. We already have a skeleton equation. So we are going to jump into counting the number of atoms on each side of the equation. You can see I've set up a chart with reactants and products and then each type of species present in the equation. If we look at the left side, there's 1 aluminum atom, 1 chlorine atom, and 1 silver atom. On the right hand side, there's 1 aluminum atom, 3 chlorine atoms, and 1 silver atom. Once you've counted these each out, we can figure out where to begin the process. Aluminum is balanced on both sides, and so is silver. That means we need to take a look at chlorine and find how to get chlorine to balance. It's important to note that by changing one of the components of the reaction, we'll need to change our grid. Okay, we'll need to update it as we change the coefficients. So it looks like we will need to put a coefficient in front of silver chloride on the reactant side. If we put a coefficient of 3, that will increase the number of chlorine atoms on the reactant side to 3. However, you can see that it also increases the number of silver on the reactant side to 3. So now we have chlorine balanced, but silver is imbalanced. We need to take another step to balance silver. So we have 3 silver atoms on the reactant side and only 1 on the product side. What we can do is put a 3 in front of the silver on the product side, and that will increase the number of our products or number of silver on the product side to 3. We can double check. It looks like it's balanced, but if we count the aluminum on each side, there's 1 atom. If we count the chlorine on each side, there are 3 atoms. And if we count the silver on each side, there are 3 atoms. So this is a balanced chemical equation. Here's a practice problem. We have dihydrogen sulfide and oxygen react to form sulfur dioxide and water. What we need to do, what I want you to do is just pause, and you will have a chance to work on the problem. When you're done, just unpause it, and we will go through the solution. Good luck. Okay, I noticed that there is a solid symbol after my H2O. That should be a gas. I apologize for that. Getting back to solving this problem for a balanced chemical equation, the reactants, counting those, there are 2 hydrogen. The subscript after the H indicates that there are 2 of them, 1 sulfur, and 2 oxygen. On the product side, we have 2 hydrogen, 1 sulfur, and 3 oxygen. So the place it looks like we're going to want to start for fixing this is with the oxygen. So let's go ahead and increase the oxygen with the H2O. I'm choosing to increase the H2O because I noticed that on the reactant side, oxygen always comes in sets of 2. So we need to get the oxygen on the product side to an even number. So we'll place a 2 in front of H2O, and that changes our oxygen on the right-hand side to 4, as well as the hydrogen to 4. Now, both the hydrogen and oxygen are imbalanced. I'm going to choose to work on the hydrogen next because the oxygen is involved with 3 different components in this system. So it's oftentimes best to save that for last. To balance out hydrogen, I place a 2 in front of the dihydrogen sulfide, and that increases the hydrogen on the reactant side to 4 and increases sulfur on the reactant side to 2. Now we have an increase in that sulfur, which causes an imbalance. We need to look at how to up the sulfur count on the product side. I'm choosing to use a new color here. We're going to put a 2 in front of the sulfur dioxide because it's affecting multiple things on the product side, and I want it to be clear what changes. By placing the coefficient of 2 in front of sulfur dioxide, the sulfur on the product side changes to 2, and the oxygen changes to 6. Now we have hydrogen balanced, 4 and 4. We have sulfur balanced, 2 and 2. Oxygen is the only thing that we need to fix. There are 6 on the product side and 2 on the reactant side. If we place a 3 in front of the oxygen, that changes the number on the reactant side to 6. Now we can look at our chart, verify that all of the components are balanced. We need to consider, is this the lowest possible whole number ratio for all of these coefficients with 2, 3, 2, and 2, and I believe that it is. and we confirm that we now have a balanced chemical equation. If you look at the notes in Moodle, you can see where in our textbook there are further explanation or practice problems.